In this video, I'm going to show you how to find the formula for the nth term of an arithmetic sequence given two terms of the sequence. In our first example here, we want to find the 20th term of the arithmetic sequence whose first term is 2 and whose second term is 5. Okay, so let's write down what we know. First of all, we know that the first term is 2, so let's write that down as a1 equals 2, and we also know that the second term is 5. So we'll write down that a2 equals 5. Now we want to find a20. So we want to find a20. But the problem is we're not told exactly what that is. We have to figure out what it is. The way we can find a20 is by first finding a formula for the nth term of the series and then plugging in 20. So let's use the given information here of a1 and a2 to find a formula for an. Well, we know that an, we already know a formula for that. That's just the first term, a1, plus n minus 1 times the common difference. So if we can find the first term and the common difference, then we can get a formula for an and then just plug in n is 20. Well, we already know the first term. First term is just 2. So a1, that is just 2. So we really just need to find the common difference. But this is easy because we have two consecutive terms of the sequence. The sequence is just a1, a2, a3, and so on, and we know the first two terms, 2 and 5. a1 is 2, a2 is 5, and then something's a3, and then so on, but these first two terms is really all we need. How much do we add to get from the first term to the second term? That's the common difference. And we can find that by just subtracting. 5 minus 2 is 3. So we're adding 3 every time. We just get that by subtracting the first term from the second term. And that is our common difference. So plus 3, that's our common difference. Okay, so now let's write down this an formula here again with the numbers substituted. So an is a1. a1 is just 2. And then we have to add n minus 1 times the common difference, and the common difference is just 3. So there we go. So there is our formula for an, and now we just need to plug in n equals 20, and we'll be good to go. But to make our lives a little bit easier, let's simplify this formula first. There's an n minus 1 times 3, and we can simplify this by distributing the 3. So we'll have an equals 2 plus, and then multiply the 3 to both of these terms, so plus 3n, and then minus 3, and then we can group that up. An equals, we'll just collect the like terms. 2 minus 3 is just minus 1, and we've got a 3n, so just 3n minus 1. Okay, so now this is a lot easier to do the computation, plugging in n equals 20. So we just find that a20 is equal to 3 times 20 minus 1. So a20 is equal to 3 times 20 is 60 minus 1. So a20 is just equal to 59. And there we go, we're done. Alright, here's another problem, which is similar but a little bit trickier. We want to find the formula for the nth term of the arithmetic sequence whose first term is 5 and whose 16th term is 35. Okay, so let's write down this information. First term is 5, so a1 equals 5. And 16th term is 35. That means a16 is equal to 35. And we want to find the formula for an. Again, remember that the formula for an can be written like this. We just take the first term, a1, and then add n minus 1 times the common difference. But in order to complete the formula, we still have to substitute in the first term, a1, and the common difference. But we have a1 again, so there we go. a1 is just 5, so we can put that in. But how about the common difference? We no longer have two consecutive terms, so it's not as easy to compute the common difference. But we'll deal with that in a moment. For now, let's just substitute in the first term, a1. So an is equal to 5 plus n minus 1 times the common difference. Now, to solve for the common difference, why don't we set up an equation using what we've got for the 16th term here? we can just plug in 16 for n, and we know what a16 is, so then d will be the only variable left in our equation here. So let's move that over here. We'll say a16 is equal to 5 plus 16 minus 1 times the common difference, which we don't know yet, but we do know a16, that's just 35. So 35 equals 5 plus 16 minus 1 is 15 times the common difference. And now we've got an equation that we can just solve for d. So let's go ahead and do that. Let's subtract 5 from both sides. So we get 30 equals 15d, and then we'll divide both sides by 15 to get 2 equals d. And there's our value of d, and now we just have to substitute this value 2 in for the common difference, and we'll have our nth term formula. So let's write that down. So an is just 5 plus n minus 1 times d. The difference, d is 2. And just to make it pretty, let's go ahead and simplify this. We'll multiply the 2 to both terms in the parentheses here and simplify. So an is equal to 5 plus 2 times n is just 2n, and then 2 times negative 1 is just negative 2. So 5 plus 2n minus 2. So an equals, well, we've got a 2n here. That doesn't combine with anything else, but the 5 minus 2 does combine. 5 minus 2 is 3. So we've really got an equals 2n plus 3. And there we have it. We're done. Here's the final example. We want to find the formula for the nth term of the arithmetic sequence whose fifth term is 30 and whose 16th term is negative 14. Again, let's just write down our information here. a5 equals 30, and also a16 is equal to negative 14. And we want to find the nth term. Our nth term formula is just an is equal to a1 plus n minus 1 times the common difference. Okay, so we need to find a1 and we need to find d. And that's a little bit harder in this problem. First of all, we don't have the first term of the sequence. We only have the fifth and the 16th term. Second of all, we don't have consecutive terms, so we can't just subtract them to find the common difference. So how are we going to find a1 and d? Well, we can use our bits of information here. a5 is 30, a16 is negative 14. We can just plug these into the general formula and come up with a system of equations that we can solve for a1 and d. So let's go ahead and do that. So plugging in a5 equals 30 into this formula, that's just plugging in n equals 5. So we'll write a5 is equal to a1 plus 5 minus 1 times d, and that becomes, well, a5 is just 30, so 30 is equal to a1 plus 4d. Okay, and now how about a16? So doing the same thing with a16, we have a16 is equal to a1 plus 16 minus 1 times d. And then substituting for a16, that's negative 14. So negative 14 is equal to a1 plus 15d. And now we have a system of two equations that are in a1 and d, and we can solve that system for a1 and d. So why don't we just solve this system by elimination? We have a1, a1. If we subtract, then we can eliminate a1, and then we'll just have an equation with d. So why don't we do that? So subtracting the bottom equation from the top equation, 30 minus negative 14 is like 30 plus 14, which makes 44. And then the a1s will cancel. And then 4d minus 15d is negative 11d. And then we can just divide by negative 11 and get negative 4 is equal to d. Great, great. And now we just need to solve for a1. And why don't we just plug, we'll plug negative 4 equals d into, say, the top equation here. So if we do that, then what we get is 30 equals a1 plus 4 times negative 4. So 30 equals a1 minus 16. And that means that adding 16 to both sides, 46 equals a1. Okay, great. So now we've got d, we've got a1. Let's just plug him back into the nth term formula and we'll be done. So an is equal to a1. a1 is 46 plus n minus 1 times the common difference. Common difference is -4. And let's just simplify this. So an equals 46 plus -4 times n is -4n. And then plus -4 times -1 is just 4. Okay, so last step, collecting our like terms. 46 plus 4 is 50. So an equals 50 minus 4n. And that's it. We're done. So now we're learning how to infer some properties of arithmetic sequences from a little bit of initial information. And in the future, we'll also learn how to quickly compute more properties of arithmetic sequences, such as their means.